Hi, welcome to another mini lecture in pre-calculus. Today's topic is inverse functions, rational case. So here we have rational function given. So rational simply means ratio of two polynomials. So if we divide two polynomials, whatever we get, it's called the rational function. What we want to do is to find the inverse of it, find the domain of the inverse, and find the range of the inverse. Let's go through these steps. The topic is very similar to what we have done in the previous couple of lectures. What is different here is that the function we are dealing with is more complicated than those. In fact, the more complicated the function is, the harder it's going to be to find its inverse. And there are actually very few functions that we can find its inverse by simple recipes that we are describing. In general, you have to resort to some sort of approximation. So I'm going to leave this particular function for you to study and just pick something very similar to it and work off of that one. Okay, let's pick a function. So I'm going to call something h of x to be, again we said this is a rational function, means a ratio of two polynomials. Now the polynomials we are considering are simple, they're just linear functions. Ratio of these two, so 7x minus 2. 5x minus 3 over 7x minus 2. We want to find, what do we want to find? We want to find h inverse of x. What does that mean? Here's a formula for finding a certain output. X is the input and the output, which is called h of x. Let's simplify it by writing y for that, so we have less to write. 5x minus 3 over 7x minus 2. So here's a formula. If you put x in it, it gives you your y. Inverse function means if I give you y, can you find the x for me? That is, if I give you a number here for y, can you find the x that gave rise to that? Well, it's rather simple. Let's start. We write our function 5x minus 3. So what we're really doing is solving an equation. How is this an equation? We are trying to find x. Let's focus on that green box there. We want to isolate one single x on one side, and y and a bunch of other numbers are all going to be in the other side. So how can I isolate x? In this case, first we cross multiply, so we'll have y times 7x minus 2 is equal to 5x minus 3. Again, remember our idea is to catch x. So let me again emphasize, we are trying to bring all the x's on one side and collect them. I multiply it, so I get 7x times y, 7xy minus 2y is 5x minus 3. Again, we are far from our goal. How can I isolate x? I bring all the x's to this side. So when I bring 5x to the left side, it becomes minus 5x if you wish. So when you take something from one side of the equation to the other side, its sign flips from positive to negative. In high school they write minus 5x here and minus 5x here, and they actually do subtraction. When you come to university, you do that a little bit faster. We say we're just taking a number to the other side and changing the sign of it. We do the same thing to this 2y because I want to isolate x by itself. So 2y comes to the other side and that one also changes its sign from negative to positive, and I still have the 3. Okay, or do it the way you did in high school. But to get this one, add a 2y to both sides of your equation. We're still trying to catch x, so what's the idea now? I factor the x, I get 7y minus 5. This is 2y minus 3. I divide the right hand side by the coefficient of left hand side. I get x is equal to 2y minus 3 over 7y minus 5. So that's the what we are requiring. If I give you x, can you find y? Well, that is function h does that. If I give you y, can you find x? Well, take the y that you have, plug it in this formula, and you get your x. So that's the inverse function. So this is 2y minus 3 over 7y minus 5. You notice that the numbers are the same, but their places have changed. That's not accidental, always happens like that. Now comes the issue of naming. If this is called h of x, so this was h of x, what is this? This is h inverse of y. Okay, by definition, it is called h inverse. As we mentioned previously, we always express our function in terms of variable x. It's just a matter of convention. There's no mathematical meaning to that. So we always have a final step here, which is instead of y we write x, instead of x we write y. So this one we write it y is equal to, this is now h inverse of x. That's the definition of the new function. Instead of y we write the x 2x minus 3 over 7x minus 5. So this was the original function. This is its inverse. So for finding inverse function of a rational function, this is the recipe to follow. So you cross multiply, bring all the x's to one side, factor and divide, you get the x. At the end, what you do is that you exchange the letters of x and y. Instead of y you write x, instead of x you write y, only because we are accustomed to expressing our function in terms of x. No other reason for the last stage. Okay, what other questions did we have to answer here? Issue of domain and range. So let's just go briefly mention what these issues are. So what's the domain? Domain is set of all numbers that can be used. So domain of y is equal to, say, h of x is set of all numbers that can be used for the input value x. What's the range? Again, range of the same function, a set of all numbers that are produced for the output y. Set of all values of y. Now there's an interesting relationship between domain and range of the original function and domain and range of the inverse function. So let me just go ahead and write my function again. So my function was y is equal to h of x is equal to 5x minus 3 over 7x minus 2. The easy question of this is what is domain of our function h? Well, what x's can you use in this expression? Well, that brings up another question, why shouldn't you be able to use a number for x? Well, because you might end up trying to perform an operation that is not allowed in mathematics, or in mathematics we are considering. One of the basic operations that's not allowed is division by 0. We don't want to have an input x value that forces us to divide by 0. So that's perhaps the most significant, and outside of that we have other cases that we do not use an input x value if it leads to a negative entry inside the radical and such. That also makes the x not to be acceptable. So what x is not acceptable here is whatever that causes the denominator to be 0. So if we go ahead intentionally make the denominator equal to 0, see if such an event ever happens. Well, of course it does. X is equal to 2, 7. It's a root of this. It's a point that is not allowed inside our domain, because if you actually insist in using 2 over 7, you're causing the denominator to be 0, and the division by 0 is not allowed. So then we come and say the domain of x is all x's other than 2 over 7. We have several ways of describing this. Well, that inequality by itself, another way to describe it is to say all the way from minus infinity through 2/7 is okay, and then you have to jump over 2/7 and take a union of that with the set of numbers that come after 2/7 and go all the way to infinity. So that's the interval notation. This is called interval notation. And a third way that we can describe our domain is to draw a line and say, okay, this is the origin, this is say 0.1. Guess where 2/7 is. Well, 2/7 is about 0.28, etc. Somewhere here. So that has to be excluded. So we are allowed to stay to the left of this or stay to the right of this. So this is the right component, and of course this is the left component. You can be in either of these two sets, but not right on top of 2/7 itself. Easy way to find this easy way to find a range of a function is through the through the domain of its inverse function. Let's write this thing. Range of h is same as a domain of h inverse. Why is that? Well, if you ask me a certain h is in the range or not, I put that number here and try to find x for it. Well, if I succeed, well, that y is in the range. If I don't succeed, it means that y is not in the range. Well, we have already automated all of this thing. We have h inverse. Let me write it. H inverse, which was 2x minus 3 over 7x minus 5. So I ask myself, what number is it that is not allowed to be used here as a, that means what's the domain of this one? Well, just like what we saw in this case, the number that is not allowed here is 5/7. Here x is not allowed to be 5/7, and not the way we describe it is that the range of h is all numbers other than all numbers. Now this is the output y, all numbers other than 5/7. That's going to be the range of h. Well, just like in this case, we can write this thing three ways. I can write it all numbers from -infinity to 5/7 and union with 5/7 through infinity. I can draw a real number line, 0 and 1, and 5/7 is somewhere on this line. And I can either stay to the left of it or to the right of it, and then I'll be okay. That's part of the range. Now an observant student notices that this 5/7 is exactly what the number that you see here, 5/7, the ratio of a coefficient of x to the coefficient of y. That is exactly the number that's going to go missing from the range of our function. Okay, I'm going to explain that shortly, but let's go ahead and look at the last stage of the problem. What does it ask from us? It is asking for domain and range of H inverse. So it's asking for us, we described what was the domain and range of H. What's the domain of H inverse? What was H inverse? Let's just remind ourselves again. H inverse was the number, the equation that we wrote here, 2x minus 3 over 7x minus 5. Domain of this will be all x's other than the x that makes the denominator 0. So 5/7 is out. The range of H inverse is all the y's that you can get, and we said the coefficient of ratio coefficient of x in the numerator and denominator, that's what is going to be missing from our range. That's going to be 2/7. So you notice domain of H inverse is looking same as the range of H, and the range of H inverse is same as domain of H. Let's go ahead and also take a look at this thing through so our function was y is equal to 5x minus 3 over 7x minus 2. If you remember these functions from your previous class, it's actually a graph of a hyperbola. So in this hyperbola you see that there is a rupture. Let me expand this thing a little bit. You see that the graph of the function starts from the left, goes to infinity, and then all of a sudden it's cut, it erupts and starts from the other side and comes out and goes to infinity. Where is it that this cut is going to happen? That cut happens at exactly root of the denominator, which was what? X is equal to 2/7. That blue line is where x is equal to a number that makes this denominator 0. Division by 0 gives you infinity, and that causes the graph to rupture to infinity. Okay, so that point is missing from the domain because you're dividing by 0. What is it that is missing from the range? You see that for all the y values here, for example, if I pick some arbitrary value for y, say y is equal to 1. If I say y equal to 1, this is the x that causes that. Okay, so the x of this thing is minus 0.5. Now if I choose a different value of y, like 2, the x that gives me the 2 is 0.111. If I change this thing to 3, well, I get another point for my x. What if I lower this thing? What if I come to 1? So this is what we saw before. What if I come a little bit less than that, 0.9? Now the x that gives me that output of 0.9 is at minus 0.923. What if I go lower? My x keeps marching toward the left. As I go lower and lower, there comes a point at which this green line does not intersect my graph anymore. And at what point is that? Is at 5/7 ratio of coefficient of numerator to the denominator. If you look at that, and let me pan this graph, you see that the green and red do not meet on either side. They come very close to each other, but you have to go all the way to infinity to catch that output. So that particular height, that particular 5/7 is not part of one of the heights of the graph, and that's what is missing. So in the domain you have to skip 2/7, and in the range you have to skip 5/7. That was for original function 5x minus 3 over 7x minus 2. You can do the exact same thing for the inverse function, and then you will see in the inverse function this value 2 over 7 shows up for y, and the value 5/7 shows up for x, and that's what we said the inverse functions do. It's you are essentially just exchanging the input and output, and that's the reason why what we observe here. So let's state as our final statement for this lecture the following: the domain of, this is always true, domain of H inverse is same as range of H, and the range of H inverse is same as the domain of H. Let me try to explain one more time. If you have a function H, let's give some memorable names to the columns of these things. Suppose you have a menu. On this side you have the item, and on this side you have the price. So you have some items, say I don't know, hamburgers, soup and salad and so on, and here are the prices for all of these things. Now assume different items have different prices. You can make a different kind of a menu, not as common as the menu always say, but perhaps prices are listed first and items are listed on the right. For the original, for this new menu, this is going to be called H inverse. For the original menu, whatever is here is called domain, and whatever is here is called the range. So domain is set of items, and the range is the set of prices. If you decide to make your menu in this style, sometimes you go to a store and they ask you how much do you want to pay. So you want to buy a television and they keep showing you so many things and they get tired. At some point they want to figure out, well, how much do you want to spend? Based on the amount that you want to spend, they show you items that match or in that kind of a neighborhood. If they do something like this, then the set of prices, this is what's going to be called the domain, and then these are going to be called the range. Let me write my so these are whatever you have here is called domain. Whatever you have here is called the range. In this case, again, whatever you have on the left is called the domain, and whatever you have on the right is called what is range. But if you notice, these prices are same as, of course, these prices. There's nothing peculiar about that. So domain of H inverse turns out to be naturally same as the range of H, and similarly the domain of H, those items are exactly the same items that you have here anyway, and so the domain of H is same as the range of the other one. Sometimes when they write it in a table like this, it sounds like they're saying something very significant, but really they're just saying something very trivial. There's nothing really all that significant about that statement. Okay, so this brought us to end of this short lecture. So what we learned is that if a rational function is given to us, how do we find its inverse? That was the meat of the discussion today. And then we had a discussion about the domain and range. So domain is limited by the number you cannot put in the denominator here, which is the root of the denominator. That's rather obvious. The range was a little bit more complicated. What number goes missing? And for rational function, that's easy to tell. The number that goes missing is a ratio of coefficient of x in numerator and denominator. That's the number that is taken off. Okay, so you go ahead and answer this, and then until next meeting, good luck and God bless.